Hello Internet. While working on a future video, I offhandedly wrote Venus, the closest planet to Earth. But later, while editing, I thought, let me check that. Which led me to this video by Dr. Stockman explaining how, no, Venus is not the closest. This blew my mind and I contacted the author to adapt his video into the one you probably just watched. It blew my mind not just because it was surprising, but also because I taught physics for years and probably said Venus is the closest planet dozens of times without ever thinking about it. How does that happen? First, asking the precisely right question is vital. Which planet is closest is not the precisely right question, because it's really made of 4 parts. Which planet ever gets the closest? Which planet is the closest for the longest time? Which planet has the shortest average distance to Earth? Which planet takes the least amount of time to travel to? The answer to the first one is Venus. The second to Mercury. The last, it's complicated, get a physics degree. Literal rocket scientists think mostly about that last question, and the rest of us are probably vaguely asking about the first, when we say which is the closest. Because we are not thinking about the planets in motion. If we were, we'd ask something closer to questions 2 and 3, which is what the main video is about. Mercury, on average, has the shortest distance to all the other planets. And for the inner planets, it's also the closest planet most of the time. But to get an answer that precise requires a precise question. Unlike the way things are done in school, where questions yield knowledge, it's knowledge that yields questions which yield knowledge. Now, it's hard to think about the raw knowledge of everything all at once, so we condense down part of what we know into a model to help us think, like with the line of the planets. But as with fuzzy questions, models can trick us too. Which planet is the closest looks like a simple and easy question when the solar system is shown this way. Like, even when you know this isn't really how the solar system looks, can't possibly be. In my old video about Pluto, where I sound like a completely different person, I cover this exact point as I've often done in class. If we take this diagram and adjust for the correct sizes of the planets, it looks like this. Think about it: if Jupiter was this close to Earth, it wouldn't look like a dot in the night sky, but would be rather overwhelming. So it must be really far away. Still, the model jets into your head in ways you don't notice and lets you ask imprecise questions, easily but insufficiently answered. The result is something that's retroactively obvious can hide for a long time. The fact about Mercury being the closest on average feels like something Newton could have noticed. But it wasn't, until this year, which is crazy. It's a property of concentric circles. Something Pythagoras, were he not so obsessed with triangles, might have noticed. So I love this fact about Mercury being the closest planet, depending on exactly what you mean by closest, because it's a fantastic example of how, if you can get rid of old or incorrect models from your head and think clearly in a way to ask a precise question, the universe awaits with new knowledge for you to find. Isn't that great?